Welcome to Psiquis-X. I decided to test my autonomous AI engine, Psiquis-X, with a classic, time-consuming junior analyst task, extracting 3 consecutive years of GAAP metrics from Nvidia's financial reports. To simulate a real-world scenario, I provided it with 3 massive, unoptimized PDFs representing fiscal years 24, 25, and 26. We are looking at hundreds of pages of highly dense, unstructured financial data. However, right from the very start of the execution, the engine did something completely unexpected. Text to predetermine it instead of blindly brute forcing all 3 documents and wasting expensive API tokens. The orchestration layer first analyzed the core objective. It intelligently deduced that the FY26 annual report already contained the necessary historical baseline data for the previous 2 years. Acting as a true autonomous agent, it deliberately dropped the redundant FY24 and FY25 PDFs from the processing queue. This single autonomous decision immediately optimized the entire data pipeline, drastically reduced the expected latency, and saved massive amounts of unnecessary compute time before extraction even began, to process the remaining data without suffering from the lost in the middle context window effect. Psiquis-X dynamically slices the document into dense, 15,000 token chunks, but to actively prevent hallucinations. It automatically injects a specific digital fingerprint and page metadata into every single text block. From there, the data enters what I call the Courtroom architecture. This is an adversarial multi-agent loop where a designated Skeptic agent aggressively attacks the extracted data looking for flaws, while a judge agent evaluates the output against strict, deterministic, Pydantic. If a financial metric cannot be mathematically verified and cross-referenced by the agents, the system completely rejects it. Because enterprise clients don't want simple chat interfaces. The final output is a natively generated presentation-ready Excel dashboard, but doesn't just paste numbers. It mathematically calculates year-over-year variance, identifies key signals like operational leverage, and builds native FinOps charts directly into the spreadsheet. Finally, the adversarial loop evaluates its own performance, assigning this specific extraction an audit confidence score of 98 out of 100. The ultimate enterprise feature is the raw data traceability tab. Every single number you see is mapped directly to its exact source file, specific page reference, and the literal text snippet. There are absolutely no black boxers here. Finally, we look at the FinOps framework audit. Replacing hours of manual analytical labor took exactly 290 seconds and cost just 3.5 cents in total API calls. This is how you build deterministic, scalable AI for the financial sector.
Updating EVA sequence immediately.